Today we're going to make a change and go to proving triangles similar in geometry. So our focus today really has to do with proving that things are similar. Now that's got a lower threshold of being able to prove things similar than to prove things congruent. Remember when we were trying to prove that things were congruent, we would go through and have to do 3 angles in one are congruent to 3 angles in another. 3 sides in one are going to have to be congruent to 3 times, or is going to have to be congruent to 3 sides in the other. Now it's going to be a little bit different, because with similarity, we have to have kind of this idea of being able to prove that things are congruent as far as the angles, but the sides we really only have to prove that they're related by the same ratio. And it has to be the same ratio for all sides. So let's take a look at the 3 that we're going to focus on for this. Now one of these is really brand new to us, this angle, because that never was something that we talked about as far as congruency at all. So if 2 angles in one triangle are congruent to 2 angles in another, then the triangles are similar. Okay. Now one of the other ones that's here is side angle side. Side angle side is also something that we saw with congruency, but now it's going to make, obviously its appearance here. Do remember that this angle has to be the included angle. So it has to be 2 sides, and the angle that's formed by those 2 sides in one triangle is congruent to the same in the other. Also, side is something that we talked about in congruency and is also making its appearance in the similarity chapter as well. So on number 1, it says, explain why these triangles are similar. Now, first of all, we can see that it has these 2 angles that are already congruent. They're telling us that because they're both 45. I can also tell in this one that those 2 angles are also equal. And those 2 angles would be vertical angles. So once you get those vertical angles, then I have 2 angles in one that are congruent to 2 angles in the other, so the triangles are similar. So the triangles are similar by angle similarity. Okay, let's take a look at another one. Pull this up, and I'm just going to pull the shade over so we can just look at one at a time. And really our directions are, what can you conclude if the triangles are similar? So in this one, all we know are the sides. So we're praying to God that side is going to be what works, because that's our only chance. If that's true, then we have to show that all of the proportions are the same. So let's start with this one on the top and this one on the bottom and kind of compare them. So if I go to pair these up, probably the easiest thing to do is if I look at this, 4 is the biggest one. Over here, the biggest one would be 6. So 4 and 6 would have to match up, and that is going to equal if I were to reduce that 2/3. Now, if I made that a decimal, it'd be 0.6, the 6 is repeating. We just want to keep that in mind, because sometimes it's easier to compare as a fraction, sometimes it's not. Okay, if I were to look up here now, my smallest is 2. My smallest over here is 3. So I could already tell that those 2 seem to match. So my last one would be, the middle one here would be 3, and the middle one here would be 4.5. Now this is where it may be really helpful to actually take it and divide it out in your calculator. So if I were to divide this, it'd end up being that 0.666 that keeps repeating. So these would be triangles similar by side similarity. Has to be all equal to the same ratio, or if you want to put it in decimal versions to make it easier to look at, that's fine. Okay, this other example. So I'm looking, I've got one angle, so I can't do angle. I don't have 3 sides, so I can't do side. So side angle side's my only hope. Now side angle side might work with this one, at least I have a hope. But on this one, the side angle and then the wrong side is marked. So it's not a side angle side in this one, even to get the general setup done. So this one is not enough information. Now that's what a lot of these problems in this section are going to look at. Do you have enough to prove this? So let's take a look at another one. Okay, this one says that MX is perpendicular to AB, which means that I know that these have to be my little 90-degree angles down here. Explain why the triangles are similar and write a similarity statement. So first of all, if I look at this big triangle, it has a 58 degrees in it. This smaller triangle has a 58 degree in it. This angle is 90 and this angle is 90. So in this one, these triangles would have to be similar by angle similarity. Now we're actually going to have to pair them up. So let's take a look at this. So if I do triangle, let's do AXM. Is similar. Now A is the blue one, so we got to go with blue over here, which is B. Then the yellow, which is X. And then K. When they talk about similarity statement, that's like a congruency statement that we wrote in other chapters. And I'd have to make sure that these letters match up with these letters here. Now, if the color helps you, if it helps you to know that, that B and A are both blue, if it helps you to know that the X's are yellow, and then the M and the K aren't marked, that's perfectly fine with me, as long as I can see what you're doing in your picture, that you've actually gone through and labeled things. Okay, let's see if we can get one more in before our time's up here. Explain why the triangles must be similar and write a similarity statement. So first of all, I can tell on both of these that they have two sides here and two sides here. I can also know that these two angles are going to have to be congruent because they are vertical angles. Which means that we have a prayer of being able to do side angle side as long as we can prove that. So that means, first of all, if those are vertical angles and they're congruent, that means that those angles have to be equal. Let's just prove the sides now have a ratio. So let's go from here to here. So between these two, 18 and 12 on the small triangle, 18 is the largest. So the largest over here would be 36. And that reduces down to 1/2. Now between these two, 12 is the smaller. Between 36 and 24, 24 is the smaller. So they both reduce down to 1/2. Same ratio. That means that these triangles are similar by side angle side similarity. That also means that I have to go through and actually put the triangles in order. So on this one, add a little bit more color. This Z that's down here comes from the green to the longest side. From green to the longest side, that would be here. From green to the shorter of the two sides, I know would go here. From the green to the shorter side, I know in this other triangle would be here. Just to help us get organized. So this would be Z, V, W. So Z, V, Y, excuse me, I'm sorry. Z, V, Y. So yellow, green, and blue. So yellow, green, and blue over here would be X, V, W. Adding that color on gave us another piece of point of reference to be able to make sure that we had things lined up in the right way.